Hi everyone, I'm Rebecca Clements, a PhD candidate in Biomedical Engineering, and today I'll be talking to you about working out the blood vessels in your brain. Have you ever been watering your garden or washing your car only to realize that no water is coming out of your hose because it has a kink in it? Well, a stroke is kind of like that. Strokes occur when a blood vessel in the brain becomes blocked, preventing the flow of oxygen and nutrients to certain parts of your brain. And just like the flowers in your garden begin to die if they're not getting enough water, the cells in your brain begin to die if they're not getting any oxygen. And strokes are relatively common. In fact, in the next 40 seconds, someone in the United States will have a stroke. And strokes can have debilitating consequences affecting your movement, sensation, ability to do everyday tasks, learning, and more. But what if we could change the next 40 seconds and prevent that stroke from ever happening? Maybe even a few months ago, this person was feeling completely fine, and they might have even gone to the doctor and gotten a clean bill of health. There are some treatments that can prevent stroke, like a special type of surgery for clearing out narrowed blood vessels, but these treatments have risks and they're not for everyone, so the challenge is knowing who's really most in need of these treatments. And that's where my research comes in. So today I'll be talking to you about a new measure of brain health that you can think of as a stress test for the blood vessels in your brain. I'll tell you what this measure is, some challenges related to measuring this, and how my research is going to address those challenges. Maybe you've heard of a stress test for your heart where doctors ask you to run or walk on the treadmill as fast as you can to try to better understand how your heart responds under pressure. But stress testing your brain is a bit more complicated because your brain is encased in your skull, and it's hard to really know what's going on inside of your brain without invasive procedures. This stress test uses magnetic resonance imaging, or MRI, to non-invasively take pictures of your brain. So instead of asking you to run on a treadmill, instead we just ask you to hold your breath for short periods to try to exercise the blood vessels in your brain. So while you're in the MRI scanner, you see these instructions that tell you when to hold your breath. And when you're holding your breath, it makes the blood vessels in your brain expand. So we can use the MRI pictures to measure just how much the blood vessels in your brain expand, which we think can tell us about how healthy your brain is. And we think that if your blood vessels expand less when you hold your breath, this could mean that you're at a higher risk for stroke. So after the stress test is over, we get these really cool pictures of your brain. So on the left, you can see some example pictures for a healthy brain, and then on the right, you can see some example pictures for a brain at risk for stroke. And you can see that regions in both pictures that are more yellow had a higher response to holding your breath, meaning that the blood vessels in that area expand more when you hold your breath. And then the regions that are more red had a lower response to holding their breath, meaning that the blood vessels didn't expand as much. So if you look specifically at the area circled in white, you can see that in the brain at risk for stroke, the blood vessels in that area did not expand as much compared to the healthy brain. And we think that this could tell us that this brain is at risk of having a stroke specifically in this area. The potential of this technique is really exciting. And as we work to introduce it clinically, there are some challenges that we need to address. The first challenge is that people tend to move their head a lot while they're in the MRI scanner. And this can affect the quality of our MRI pictures and make it harder to evaluate the results of the stress test. So my research is working to address this challenge by developing novel analysis methods to help clean up the data so that we can still trust the results even if someone moved their head a lot. The second challenge is that we give people some really difficult instructions to follow while they're in the MRI scanner. We ask them to only breathe through their nose and also to remember to exhale immediately after they stop holding their breath, which is often counterintuitive and difficult to do, but if people don't follow these instructions, we often can't even use the data that we collected. So my research is focused on developing novel methods for recovering data that was previously unusable because people didn't follow the task instructions. And the last challenge is that because this technique is relatively new, there are a lot of different ways to analyze the data that you get from the MRI pictures, and there's not a lot of agreement on which method is actually best, which makes it really hard to translate this into clinical settings. So my research is focused on making robust comparisons between all of the methods so that we can then provide clear recommendations on the best way to analyze the data so that this technique can then be translated into clinical settings. And ultimately, by predicting stroke, we're hopeful that this could lead to stroke prevention to help identify candidates for preventative stroke treatments like the special kind of surgery you see here that clears out plaque from narrowed blood vessels in order to ensure that blood continues to flow freely. And my research can have benefits even just beyond measuring stroke risk. So this stress test that I'm focused on improving could also be used to predict recovery from stroke so that we can identify the most appropriate treatments for specific individuals. And it could even help us understand other diseases like Alzheimer's and multiple sclerosis and how those diseases affect the brain so that we can develop better treatments. And not only that, but the stress test could also help us understand how other factors like aging and exercise impact your brain health so that we can not only focus on preventing disease, but also promoting lifelong brain health. Thank you.